All right, hi students. Sorry for the delay there. I'm going to walk you guys through molarity by dilution. This was assigned Tuesday, March 20th. And just going to walk you through here how we go about solving these. So if you get stuck or need a pause, feel free to do so. But we're going to get started, get right to it. So in the first one, how much concentrated 18 molar sulfuric acid? So how much, that would be a volume. Okay, that's going to go with that concentration, is needed to prepare 250 milliliters of a 6 molar solution. So notice the preposition, 250 mils of a 6 molar solution. They go together. Now, 6 molar is smaller than 18 molar. So 18 is our M1. How much is our V1? That means 250 milliliters is V2. And 6 molar is M2. We set up our equation, M1 V1 equals M2 times V2. Plug in what we know. We know M1 is 18 molar. We don't know V1. M2 is 6 molar. And V2 is 250 milliliters. Now, it doesn't specify what unit of volume to solve for, but since the first volume, or the only volume we're given, is in milliliters, it's safe to respond in milliliters. Keep it consistent. Okay. If we go back to solve for V1, divide both sides by 18, and doing so, V1 is 83 milliliters. So we would take 83 milliliters of this concentration, add water to get 250 milliliters of the less concentrated solution. Number 2, how much concentrated 12 molar hydrochloric acid, so it's a volume that's going with this concentration, is needed to prepare 100 milliliters of a 2 molar solution. So there's relationship. 100 milliliters goes with 2 molar solution. Now the 2 molar is less than 12, so 12 is M1, 2 is M2. That means that this volume is V2 because it's of the 2 molar solution. And so again, we are solving for V1. So our equation, M1 V1 equals M2 V2. We have 12 molar for M1 times V1, we don't know. And then M2 is 2 molar times V2, which is 100 milliliters. Okay, the line above the 0, don't worry about it. It just means that in honors, when we talk about significant figures, that we are precise up to that decimal place, but don't worry about it for now. When we solve for V1, dividing both sides by 12, we get 17 milliliters. Okay. In 3, to what volume should 25 milliliters of 15 molar nitric acid be diluted to prepare a 3 molar solution? Well, 15 is bigger than 3, so that's M1. 25 has to be V1. And we're diluting it. We're making it weaker, bigger volume. So V2 of the smaller concentration, M2. So we set up our equation, M1 V1 equals M2 V2. Plug in what we know. We have 15 molar and a volume of 25 milliliters is equal to 3 molar for M2 times V2. We don't know that volume. But when we divide both sides by 3, we find that V2 comes out to 125 milliliters. Okay. 4 and 5 are like if you watch the tutorial video from Tuesday, where we had the water part to how much water. So we want to know what is that volume of water that we need. That's in both 4 and 5. Let's take a look at what other info we have. 50 milliliters of 12 molar acid. So much water are we adding to that quantity to make a 4 molar solution? This is less concentrated, so that's M2. This is M1. That means 50 is V1. So when we set up our equation, M1 V1 equals M2 V2, we have 12 molar times our V1, which is 50 milliliters, is equal to 4 molar. And V2 we do not know. I know we're solving for water, but if we set up what we have so far, we don't know that final volume. So let's solve for it. Divide both sides by 4. V2 is 150 milliliters. And recall that the volume of water is V2 minus V1. So the final minus the initial tells us how much we added in between to raise it up to 150. So 150 minus our initial of 50 is equal to 100 milliliters of water. And lastly, in 5, to how much water should 100 milliliters of 18 molar acid be added to make a 1.5 molar solution? This is going to be our V1 and M1. And I know this because this M1 is bigger in value than what we dilute it to. So M1 V1 equals M2 V2, 18 molar times 100 milliliters equals a 1.5 molar solution times V2. V2 comes out to 1,200 milliliters. So that's our final volume. So we start out at 100 milliliters. We add a certain amount of water and it goes up to 1,200 milliliters. Well, how much water was it? We would do 1,200 minus our initial 100, which is going to give us 1,100 milliliters of water needed for this process. All right, and that's it.